Yeah, it's wonderful. The only time I've worn a lab coat has been when I was visiting my chemist friend during my internship.
Everybody, welcome back again to another night at the Pigsty. Tonight we have been joined by the Weasel, Dr. Weasel, Mr Tapiocaweasel. What are we going with? I think we just went with Mr. Weasel this last couple of weeks, haven't we?
Yeah, that's fine.
Mr. Weasel, nice and
I
handy.
am a doctor, but I never planned
Oh,
on
excuse
becoming
me,
that
Dr.
kind.
Weasel. We Dr. Weasel. Okay. So,
Oh no,
if
look what I
anyone's
did.
been watching this last couple of weekends, Dr. Weasel has been popping onto the panels and stuff like that. And thank you again, man. As of last week, you became a member to the channel, so I very much appreciate that. But getting to know you a wee bit better, we've noticed, you flat out told us, look at how proud I am. You have a background in physics. So we were chatting and stuff. And considering if anyone's been watching for a while, they know it's my favorite field of science. So I thought we would come on, have a wee chat, bounce around, see if we can get a few conversations going, make some digs at Deepak Chopra, and then move the fuck on. But yeah, Mr. Dr. Weasel, if you want to give us a wee bit of your background, or, where did you order your PhD from? The same place as Open?
Yeah, Patriot University, their shipping fees are extremely, hold on. Yeah, no. Let me check my notes. Sorry. Yeah, no, I wanted to be a physicist from which is what I am. I got my PhD this past summer, and it took a long time, and it was really hard, but I did it, and it's like it's the thing I'm most proud of, in my life. But I've always been interested in science. I wanted to be a physicist from the age of 11. Um, my grandfather was a physicist, and it's always been something that I was really, really interested in. So I come from a pretty well-off background, and I kind of did well at it in high school and then college, and then I went to grad school, and I kind of did it in the very linear, boring fashion. But it's awesome because the specific field that I study is I'm an experimental physicist, and I study ultra cold atoms. We use lasers and magnetic fields, yeah, and all
Said
sorts
that
of
very
things.
much like Dr. Evil.
Yeah, Yeah, there's all sorts of lasers, and I make jokes about it all the time. I'm like, these poor atoms, we're just shining lasers at them all day, and you know, freezing them down to ultra cold temperatures that are a billion times colder than the air outside,
Well,
or the air around you.
only 273 degrees colder than outside.
Well, yeah, but it's a factor of so temperature is a multiplicative scale, and so absolute zero is just like no movement,
I
and
know
the
temperature's
things
wrong.
have
That's yeah.
9
So,
billion times. Yeah.
temperature isn't a measure of actual temperature as people understand it. Temperature is a measurement more so of movement inside a specific area, a designated area, the speed that these things are moving around in.
Yeah, most of the time, that is a much better way of thinking about temperature. Some of the time you can define temperature in weird ways in statistical mechanics. This isn't important, so we can move on. But where you can
Physics
have
rambling.
negative temperatures that make mathematical sense, and it's because physics is fundamentally black magic, and facts are meaningless, and truth is a lie.
So you have lasers.
Yeah,
Lasers.
yeah,
Shooting
yeah.
atoms.
Lasers. The laser we use. You use a lot of different lasers because when the molecules are moving, or not molecules, the atoms are moving, they're just traveling through space, and they only interact generally with other atoms that they hit, which is why we use a vacuum chamber and just put in a little bit of the atoms that we want. So they're just sort of floating around in space in the vacuum otherwise. And they're only going to react to very, very specific wavelengths of light, because that's where the discrete energy levels are. Because the energy, the way the atom and all its like subcomponents can be arranged inside can only happen in certain chunks. And so the energy is quantized, which is why it's quantum theory. It's this discretization of sort of how things can be at the deepest level that is fundamental to what quantum theory is. And because of this, they only interact with certain colors of light. So we want to move, they're going around at the speed of sound, and we want to stop them, and so that we can like shoot them with more lasers to do other things to them. Because
you not have like a really
sadists.
tiny pair of tweezers that you can just reach in and like hold it with? No.
Yeah. Oh well, optical tweezers. Yeah. If you use a color of light that's really far away, but you make it really powerful, then the atom can still interact with it in a different way, and it gets magically sucked. It's not magic. It gets sucked into the middle, and it hovers at the focus of the laser beam, which is how I trapped the atoms in the final stage of my experiment after cooling them down. And to cool them down, you just point a laser against where they're going. So you point a laser in every direction, so that right in the middle, they're always going to go in against some laser. And you make the light a little bit red compared to what the atom is expecting. And that means that only atoms that are traveling into the laser beam are going to be absorbing these photons.
Mm-hmm.
And the thing about photons is photons have momentum. They don't have mass, but they do have momentum. And that momentum is absorbed by the atom, which will then release the photon again in a random direction after typically a short amount of time.
Yep.
And so on average, they're always getting pushed against whichever laser they're traveling into. And when you point it right at the middle, they're always traveling into one of the lasers, to some degree at least.
Yes.
And so the atoms that get right there just get zapped, they get punched back and end up moving very slowly.
So by saying that you're lowering the temperature of it with a laser, what you're basically trying to describe across is it's running at 1,000,000 miles an hour and you've got a brick wall in every direction. It keeps trying to move and you're just fighting back at it to hold it in its position.
I'm throwing bricks at them. But they're bricks that only materialize if if you're moving towards them.
Yeah, yeah. It's just to simplify for everybody.
Yeah. And the bricks have a property that is the frequency of the light, basically, that determines how far you have to be running towards them. And if you tune the laser to the resonance, then that's just sort of that's generally what we mean by if the atom were at rest, or just the average of all of the atoms moving all over the place in a gas. So in a gas, they're moving all over the place, and some of them are doing this. And if you tune across resonance, you're going to hit the ones that aren't moving towards you. They could be moving sideways, but not towards you.
Yeah.
Now you can also give them extra energy, so that if they were in the middle, they heat up and go away.
Now, you are doing this for your experiment at work, or is this your dissertation you're describing?
Both. This part is that part is the optical part of a magneto-optical trap, which is a type of trap that uses the optical component I just described, as well as magnets that are going to interact with the atoms in a certain way such that they're always pushed back towards the center. And if
you had to have a reason for this, though, what were you measuring? What were you experimenting? What were you trying to disprove or prove?
So what I was measuring in my thesis work was fluctuations in Bose-Einstein condensates, which are when you cool them all down to the absolute ground state, they can't get any colder. They're not at absolute zero, but they can't get any colder. And these things are just quantum fields that are kind of big. I mean, they can be dozens of microns across, 100, maybe 200 micrometers wide, which is wider than a human hair in some cases. So they would be visible, like you could see them, but and it's in my PhD, it would have been a big cloud would have been a few million atoms. They would not at the lowest ground state. At the lowest ground state, I could get maybe 500,000 atoms. And then if you shine a light on them, then you could maybe see it if you were looking and paying attention.
But this is if I could poke a wee bit into that, more so generalized than rather just in your particular background, right? You're freezing these things down, okay? I'm going to be very colloquial and very vague, and as best I can, right? So you're freezing these atoms down, okay? And under the general understanding of what's out there in people who have an interest, like something like me or whatever, the idea of a particle is a moment in time in a field being measured. It's not actually, the fields are everywhere. When you measure an electron or you measure something like that, it's a measurement of a field, and that gives you your particular element or your particular atom. I say, making it really dumb. When you slow these things down and you have such a little thing, when they're not moving, are they still, could you represent that as an atom? It's being trapped, it's still being measured. Talking about quantum fields and getting that small, it's where the whole idea of, this quantum mythicism and the idea of that would come from, that there's dimensions all down there. When everything gets slowed down and it's all at that small quantum level. Do you think that these things, like the quantum foam, that's the word I'm looking for. Would you be a proponent of quantum foam at very low energy states and low temperatures, and zooming in as best you can? Obviously not that good.
Yeah, it's a real thing, in a sense, but I don't know what that is going to mean to somebody like Deepak Chopra, for example, to say that quantum foam is a real thing, because I have said to people before, and I think it's probably technically true, that like a cat or something, I mean, a cat is the canonical example, could, for example, materialize out of nowhere. That would not be Schrodinger's cat. That'd be like Lawrence Krauss's cat or something, I guess. I don't know.
Yeah.
But that's... it couldn't, actually, for a sufficient period of time, because we still have conservation laws.
Well, that's
things have to obey very specific rules, and
Like
The
I would be
influence
able to
that we
say to you,
see,
like I could say to you that a cat would definitely has the possibility of appearing in your room right now, but it would appear and disappear that quickly to conserve the laws. You wouldn't even see it probably.
yeah, you can express Heisenberg's uncertainty relation in a product of energy and time. So you can have a lot of really energetic stuff going on, but it can only happen over
Yeah.
crazy short time periods. And you can think about it as though like these things are kind of always happening to some extent, but the impact of that, the physical impact of that, it it isn't just like probably small. It's actually nothing. The quantum fluctuations. We literally have no reason to believe that the quantum fluctuations going on in anywhere other than maybe potentially at a weird, completely random stochastic level, other than in your brain, it it doesn't matter. Everything's decohering. You need to have a coherent system. The reason we make things cold as hell is because that's the only way to stop them from decohering. Otherwise, these these fields are just always suddenly, just kind of collapsing back into atoms, or
Mhm.
they're always atoms, and
Oh,
they're always fields
there's a
also,
question.
but
There's a
they
question.
localize.
Right. There's a question just off what you're stating, right? And I don't know what I'm trying to build into your brain on how you would see these things, right? You say
Yeah.
they constantly collapse back into atoms. Okay.
Yeah, I was gonna say, I think that's a bad way of putting it. I think that I don't like how I put that.
I would
Um,
say the reverse. That the field would be the natural phenomenon, and only when something interacts with it does it become an atom
yeah, yes, and
or an electron or whatever the fuck. Like,
then then you have this question of what is actually happening that constitutes a measurement. Why is it that if I have a photon trapped between two mirrors, or if I have an atom delocalized in this trap over 100 microns,
mhm.
if I take a picture of it, and I know I've got one atom there, and I know it's somewhere there, if I take a picture of it, I'm going to see 1 pixel on my camera light up.
Mhm.
One. Because it's, unless yeah, one.
One photon, one
So
pixel. Yeah.
one photon, one pixel, unless your resolution is, you're not pixel limited remotely. And it's blurry.
But
But
that which came first, the field or the atom?
I don't. The atom is a field, in a sense, yeah. But it's a field that, like, most of the time behaves in a way. I I think of most of the time, I think of these things as particles that, like, if I stopped it here, because I know it's delocalized, and it's sort of, that's in my mind the probability that if I made a little movie of it, I'd see it do a thing. So
Mhm.
if I have it in a trap so that it's always being pushed back to the center, and we describe these as energy potential wells. So if it's over here, it's got high potential energy and it wants to go towards the center, and if it's over here, yeah. And I will think of it like, okay, well, the atom could be over here, and then that means it's traveling this way, and that means if I wait this long and take a picture of it, it's going to be here. But if it's over here, it's going to do a different thing. But you can then imagine, if there's two atoms, you can imagine one bouncing into the other, and you can do a calculation based off of that energy, and then you just plug that equation into an integral, and so it's very powerful intuitively to think of these things, in my opinion, as literally kind of little particles bouncing off each other, like, actually.
I would say you're probably in around the same age as me, a little younger or whatever. Roughly the same age bracket. You probably would have seen the IBM. video from 80s, 90s, whatever it was, where they took the little laser or whatever it was and they moved the atoms on a sheet of something else and they wrote IBM.
Yeah.
Right? So when you're watching that visually, you have the idea of an atom being this little sphere, it's this little thing that can be moved around and stuff like that. I
Yeah.
would have been taught in school, as probably a lot of people are, you have your nucleus, which is your photons and neutrons and stuff in the middle, and you've got your electrons in what, up to 8 energy levels, I think was the basic one you were taught at, and it bounces between these energy levels, right? Then as you get older, you're told everything you learned before is bullshit. Ignored, right? So in my head right now, when I visualize now an atom, okay, if I was to visualize it in my head, this is how I describe it. Would see it. It's hard to describe it in words, but more of a mass of clouds. Like like Jupiter would be a big sphere of just clouds. This would just be a big sphere of like what looks like clouds, like electrical energy and stuff like that. And if you sliced it, you wouldn't really see definitive layers. There would be gaps and spaces, and it's more of a fuzzy nature, like a mothball type of thing.
Yeah. And that is more accurate. It is more accurate. I think that it's what when I'm interacting with atoms at the level by energy level, angular momentum is incredibly important, and it can be easier to picture angular momentum when you actually think of a thing going around sometimes in certain ways, but it's not accurate. It's this ethereal cloud, because the thing is, before it's measured, it doesn't exist in one of those spots. It exists in all of them, and it will sort of spread and interact with other waves as though it exists with all of them. You can develop an intuition for how these waves interact that is very similar to if you thought of like just ripples in a pond sometimes. Like
right, but what I'm trying to get to, and what I'm trying to is the visualization for a lot of people who need to see things, right? So especially the way that the education system is taught, I can't remember the name of it, but there's another person who is a proponent of teaching top down rather than bottom up, because we go bottom up and then you're told to ignore it, bottom up and then you ignore it. Top down and work upon that's a different route. But excuse me, we all know of different things, like there's heavy plutonium and natural and things like that, and different that can be described atoms, but with different quarks and stuff and things in them that make them different yet still the same. If I was to take a drawing and I drew a drawing of heavily plutonium, I would make the nucleus bigger. I would add an extra P or an extra N or whatever the fuck is necessary in the drawing, and someone looking at that can visualize it. Easy peasy, there's a definitive thing, extra bit in the middle. When you take a picture of it, how could you tell in your picture, or would there be a difference between, say, an atom of heavy this and a standard atom, or not? Because these are just not a physical thing that we draw on a piece of paper. How do you know that is it the same color? No, it can't be, because we reflect light. It's how
well. When you reflect light off of most objects, they behave in much more complicated ways than single atoms do. Single atoms are, I went into a very simple atomic part of physics. I went into atomic physics because it's as reductionist to some level as you can get, and still be, I think, amenable to a fair amount of intuition. And no, the short answer to the question is, in my experiment, would they look different? No, I can only see exactly one type of atom in the experiment I'm currently working on, which is
you're
strontium.
limited to working on one type of atom. Is that what you're saying?
Unless you get more lasers.
More
lasers.
Right.
Yeah. The more complicated the atomic physics is in the sort of broader subfield of atomic molecular and optical physics, where you use a lot of lasers. My experiment uses at least 6 lasers off the top of my head that I know of for
That's
like
not
different
enough lasers.
frequencies. We have
That's only
multiple
one.
ones.
Yeah, that's only one digit. We need double digit lasers.
Yeah, but if some that is because we're able to do things with one laser. We can split it into like 8 frequencies and do all sorts of different things. If you can vibrate a crystal such that if you're pointing a laser through it, the laser's going to split into multiple beams. And then you can put that through a lens and you can focus those beams and you can trap a single atom at each one of those beams. And then you can arrange those by putting 2 crystals in next to each other, and just by vibrating them in a certain way, you can arrange those beams to spell out the name of your school. I have seen in at least a third of all of the physics talks I have seen in the last 10 years, I have seen a picture of that where the people did that in their lab. I'm not joking.
Well, if you had the ability to, would you not? It's like nobody's looking. Come on.
No, yeah, I never did.
Yeah, you just
I did have an
to say
apparatus
that.
that could have done it in the first couple of years. But in the first couple of years of grad school, I was working on one experiment, and then unfortunately, one of my advisors passed away, and I had 2 advisors at the time, and so I ended up changing labs. It was a whole thing. That lab got sort of decommissioned, and the grad students got moved to different labs for the other advisor who we still had. So it worked out really well, actually, all things considered, because it's really easy in grad school to get screwed over. And I did not get screwed over by anything other than the unfortunate.
Well, more about you then, and more about your past. You said about 11. I was very similar. It was 10, 11. I got into physics. I wasn't as I don't know what way, lucky, educated, did well, whatever the fuck. You've done
Lucky.
a whole lot better and
Lucky.
got down the way that I've got down.
My parents were able to pay for college. I didn't have to take out a loan.
Mm-hmm.
Things like that. It makes a huge difference.
Taking the weight
It makes
off.
a huge difference.
Yeah. But anyway, going back further than that, in around the same age, right, as I say, 10 or 11, things like that, I could probably, not be able to point on 1 or 2 things. Like, I didn't watch E.T. when I was younger. I didn't have that real interest. I was growing up and things to watch on TV was more interesting to me. It was like Dragon Ball Z and anime and, stuff like that there was more interesting to me. But mathematics was always something I was very much enjoyed, and pure mathematics, the way it's split up over here is we had mathematics class in high school, we had physics, chemistry and biology. They were tied together under sciences, and you would get a triple A, triple B, triple C, whatever. That would be your all together. But maths was always separate to that. There was
fair enough. Yeah.
The general rule of thumb was people took 3 A-levels. I took 4. I did physics, chemistry, biology and maths. And then I dropped biology to keep mathematics for my second year, right? Because it ended up just being me and that math teacher just alone, right?
That sounds awesome.
It was, we had white coffees every morning. He was a cunt. Everybody fucking hated him. But if you understood math, he could get, it was brilliant, right? So I've just me and him for a year. And that was an enjoyable, like, not, teacher or teacher, student thing, but the mathematics, what I'm trying to say is that type of math, when I went to my physics class, was totally different. I always found physics fun. Math to me was learning how to do physics. That's how I seen it. I didn't do math because I wanted to excel in math. I did math because I wanted to do better in physics. I was generally in the stuff that we were doing in physics, for the people who did continue with it, I was generally 2 or 3 months ahead of them in the type of equations we were doing, because I'm doing it in math, and it's now coming up in physics. But physics for me was fun. I enjoyed it, and like, people hated a particular question, which was the ladder question. You have a ladder leaning against a wall, and you have to break it down into all its vectors and all its formulas and this, that, and the other. It's like, brilliant, love that shit. He hated it. People hated that, but I always found physics fun. It's enjoyable to me. It brings math to life because physics is the world, so to speak. Physics is using mathematics to describe the world around you. And we all live in this world. This is what reality is. Numbers I would consider to be, say, abstract. It's a hard fucking way to describe numbers. But you can't reach out and grab a number, but you can reach out and grab 5 apples. So the idea of numbers is the idea of numbers. But there's no idea of physics. There's theoretical physics, don't annoy me. But physics is the description of the world around us. And it's how we use the language of the world, the universal language of the world, to describe it with us. And now I'm rambling. Don't know what question I was going to ask. Going to say hello to Spackle in the chat and hand it over to you.
So yeah, I was a physics and a math major for my bachelor's degree. I have a Bachelor of Arts in math and physics. It's the joy of liberal arts colleges. And I really enjoyed sort of also just the parts that I think of as the abstract parts. I never learned any math that was not I can't directly think of physical implications for. But I am not of the opinion. I think this is related to what you were talking about. Like, math is in a very helpful to, as a heuristic sense, the language of the universe. I think that's a great heuristic way to think about it.
Yeah.
But I think that math is relationships between. So I would define the practice of mathematics at its highest level as the exploration of formal axiomatic systems.
Ooh,
you have
me.
So you have a few axioms, and you have a formal sort of way that they interact.
Yes.
Under the rules of symbolic logic, basically, to some extent.
1 + 1 = 2.
Exactly. And it turns out that if you try and start from first principles, it takes about 180 pages, I guess, to get there or something, to get to 1 + 1 = 2.
Oh yes, I remember that cult. Oh yes, I seen a video. Yeah, that's a big ass book that nobody would publish. Yeah. Yeah.
Yeah.
The whole idea of 1 + 1.
It all depends on what you consider to be actual philosophy, because then you're getting into the philosophy, but you're starting off with statements that you know are true. The historical example, which is not mathematically rigorous but everybody knows about, are Euclid's 5 postulates. And the idea is, he was doing his best, you guys. He was right in spirit. He was trying to do it right. It takes when I took a class on geometry in college that did it more formally, and it took 13 axioms to get to the Pythagorean theorem or something. I don't know if you need all 5 of Euclid's. I don't know if you need postulate 5, but and postulate 5 doesn't have to be true. You can define a perfectly coherent system of mathematics on where you have a line and you have a point through that line, and there's not just one, or there is none, potentially, parallel lines through that line that never intersect your first line. And that seemed insane to people when it was first understood in, I think, the 1800s or maybe 1700s. I don't remember. My history skills are not so great.
Well, this is why we should put you and Michael together. Michael knows the history of science, so that he's good with the dates.
I'm very interested in the history of science.
Yeah, Michael was out there at the start, although he generally isn't free for another hour or so, so I think he was just showing love, but he might be free later if we're still going, so that would be good.
Yeah, and oh, where was I? But it's I wanted to make the point that I think there's some people believe, and you didn't say this, but some people believe that everything in math corresponds to something physical. And I'm just not convinced that that is true. I
Right. So
think
that
that the world of math, it has relationships between concepts, and like the concepts exist in some sense whether we think about them or not. I think you,
well, I would
you
agree
can't
that you
start
can
with the same.
you can say 5 plus 5 equals 10, but if I ask you to reach out and grab 5, you're going to
Yeah,
grab 5 physical things.
you're not going to grab 5. it,
No.
there's no content to it. It's structure without content. It
Yes.
only refers to the structure, to the relationship between, like, it's just a map. It's not like a thing. And
Similar to the
that's
idea that
so
I can say
weird.
something is blue, but I can't reach out and grab blue. I would grab something that is blue.
Yeah, yeah, but blue doesn't have uh, blue doesn't have the same sort of logical rigor that um and this might be philosophically controversial, I'm not sure. I'm not a philosopher and I haven't read philosophy books, but mostly. And but you can't add, you can add blue and another color and you like get a third thing, but then you're thinking of more. It depends on how you do it, and you're reverting to a physical model when you do it. It doesn't have the same type of generality, I don't think. And I think that's what people like Deepak Chopra miss, because they they think that abstract just means that it can do whatever you want. I don't know, and that's not the case. Yet you can start kind of wherever you want in math, but once you've started, the entire everything you're going to discover, you're going to discover. The way you express it, you can invent if you want. But mathematics, when you choose a starting point, it the structure is set. You don't get to invent it as you go. You can add new rules, but like
Well, you see, that falls down the route
it
as well when it comes to science and stuff like that. People have this mad idea where science goes out to prove things. When the whole idea of anyone who knows anything, the science goes out to disprove what we know so that we know what we have is correct. So the only thing that you can prove is a mathematical proof. Because it
yes.
is so logical, because it is so, and I don't want to say what do you think sets math apart from everything else with that, because we can all say that it's the logical nature of it, but you can't take 6 apples from 5 apples and get -1 apple, but you'd agree that that's possible.
Yeah. Yeah. Not in the like traditional sense, but if you're thinking about a number of people who owe each other apples, and you're trying to work it all out on the blackboard before you actually start exchanging apples, then
But
having
physically,
negative apples,
there's no such thing as a negative
physically,
apple.
no, there isn't.
Yeah.
Um, unless, an antimatter apple might disagree, and everybody involved in that argument would die immediately in a fiery blast. But you're right. There's no such thing as a negative apple. And is there such thing as zero apple? You
There
can
is
not have an
without
apple, but
apple.
is
There
is
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 without
no
apple.
apple zero apple?
I would
Like
say that there is without apple.
there is without apple, with and without. You would have been it would have been very difficult to convince people at a certain point in time that with and without are numbers, in the same sense that 1, 2, 3, and 4 are numbers, and they like are, but in sort of a very weird way, I guess. And it, so without isn't zero. It's why zero took a long time to be invented.
Yes.
And I think it took a long time to be grasped, because it's
Math, if I think I'm correct, came out of accountancy originally.
Certainly, the practice of mathematics and written mathematics, I think, was for a long time originally accounting. Yeah,
Yes.
and you need to do some not trivial mathematics. You need to be able to multiply. You need to be able to add. You need to be able to subtract, which is slightly, I think, more complicated than adding because you can subtract too much and then suddenly you're confused. It's not. It can be like, what does that mean? Okay, and that can have consequences because if it's not hard to come up with examples. If you had people that are delivering you grain, and suddenly you know that this guy is going to be delivering less grain and whatnot, and y if you have a deficit ever, you're fucked. If you have a deficit, you're fucked. So like you figure out a way around it, and it's fine. And then you need to know multiplication because multiplication is manifestly handy all the time. And then that you end up having to use division. And I would argue division is way more complicated than all of the rest of them because that I've mentioned so far. I
Watching
think
my
it
wee
is
girl.
fundamentally a more difficult idea.
Yeah, watching my
Um,
wee girl learn mathematics at the minute. Now, don't get me wrong. Her, she's doing very, very well at math. She has figured out to count to 100 without having to figure out to count to 100 because all she remembers is 20, 30, 40, 50, 60, 70, 80, and 90. That's it.
yeah,
She has realized, and it's watching her pattern and how she comes up with numbers. Now, as I say, her teacher has
exactly.
mentioned that she's very good with numbers and stuff like that. And sorry, say what you said just before that. Sorry, I can. What was it you just said?
Well, now I've forgotten.
Ah,
The
watching
division
them.
was more
Yes,
division was more difficult.
watching
That's what I
her
was saying.
learn to do multiplication. She can multiply before she can divide. She finds
Yeah.
multiplication easy because multiplication technically
Yeah.
is just advanced math. As in, sorry, advanced addition.
Yeah, and it's you can. It's also visually, I think, easier for the brain to sort of process.
Well, it's
If
only
you
one
have
direction. Like if I said to you, "What's 3 times 2?" You're gonna say 6. It's one
Yeah.
answer and that's it. Where if I
Exactly.
said to you, "What is the multiples of 6?" You're like, "Fuck." Now it is only what 3 and 2 and 6 and 1, but that's a simple
Well,
example.
okay, those are the divisors of 6. The multiples of 6 are 6, 12,
Sorry,
18,
yes, okay.
24.
I'm
Yeah.
not great with labels. Labels are shit. I know concepts, man. I'm never good with
Yeah.
names and labels. But
No,
you get my
me
point.
neither.
There is
Dude, I'm a physicist. I can't tell you with confidence the difference between an isolated and closed system. I know the definitions of each, but I can't remember which one is which. Okay.
yeah, I'm useless with labels. Useless with labels.
It's
But you get my point. When you're trying to figure out what the divisors or divisibles of this, whatever it is, there's multiple answers. So going
yeah,
backwards can be more difficult to visualize in your head because it creates more patterns. Sorry, more pathways for you to work down and for you to think upon.
yeah, yeah. It's just not as sort of clear. I think also like if you have a bunch of things lined up and you have 5 of those things lined up and in a row, and then that there's a bunch of rows, you can also just and there's a reason that we do this, just visually show that, and it's 5 by 4 is 20.
Oh,
and
yes,
and
graphs.
you can just see it, and it's all one thing, and you learn to sort of be able to like just if you didn't have all of the blocks, you could be like, okay, well that's a rectangle like that big, and that's going to be a number that's this much bigger, and like
When you were
when you figure
younger,
out the correct answer, like
right?
it's so much easier. I don't know.
One thing I
Otherwise, you have
found,
to like slice it.
yeah, one thing I find that I'm not blaming anyone. It's nobody's fault, and it's the way I am relative to the teachers and things like that and all that. They're crack. But the whole apples thing, the reason I keep bringing it up and Ox has mentioned and stuff like that, is it's sort of a subconscious thing about the idea of apples and oranges and adding and things like that. That is the style of math that I was taught at a young age and how to look upon things, which learning how to do that always did I don't want to say it gave me an advantage or anything like that, but it worked for me. It was great for me. You know, this idea of all of that. The idea of when I got to university, the reason I ended up only spending as little time as I did in university is because I had an advanced mathematics class that I took. Because, you know, I'm a cocky bastard. I'm doing all this. I've got A's. I'm grand. Great. I had good teachers in high school that got me, you know?
Yeah.
And I got to university and I get a teacher, and the style of learning in university is you go learn yourself. You have more freedom, more time.
Yeah.
That to me is a problem. I need someone to show me what is going on before I can get it. So when I ask questions and I'm now feeling awful because he's telling me the same thing in different ways, different words, but the same way, and I ain't getting it, doesn't want to put the time in. You know, maybe he does, maybe he doesn't. I don't know. Didn't put the time in. I didn't put the effort in. And that's one of the reasons I left. Whenever I then, 6 months, 7 months, whatever it was down the line, still have an interest in math, still trying to keep up, feeling genuinely bad about the fact that I've had to leave. You know, you don't want to. As you say, you've been at it now for 6, 7 years when you're 11 to 18. It's your dream, it's your goal, you know. At the time, our last year got to go to Hawaii and spend 3 months using that telescope. I wanted to go to Hawaii, motherfucker, you know. And I then clicked in the space of a 2-hour lecture, watching a fucking guy in a massive auditorium in front of everybody with a big board behind him, using a fucking number board and adding a third dimension and just sticking up on it. This is where the square root of -1 goes.
Yeah.
And that clicking of imaginary numbers and being able to visualize it over seeing it in just the number form, that for me was like a kick in the teeth, sort of a...
Yeah. When you think of complex numbers as just being sort of kind of two-dimensional numbers where addition and multiplication mean also rotating in addition to extending and bouncing around on just the number line, it's why the number line is awesome, because the number line like gives you an intuition for how things are sort of set up, and then you just extend that and you're like, okay, you add, but you also add the other component as well.
Yes.
And if you multiply the length, and you add the angles.
It gives you a visualization.
It's a simple rule. It's a simple rule that if you put it that way, you can just write down a complex number as a radius and an angle, and it loops back over every 2 pi, and it makes it so clear. And then and that circle is showing you understand why it's crazy. You understand why e to the power of I times pi, for example, is -1, because e to the power of pi over I times pi over 2 gives you that, and it's because e
is a magic number.
Because e to the I theta equals cosine theta times I sine theta, and that is fucking amazing. That's amazing. And
you've went a wee bit far from me now. It's been a while, but I'm getting what you're saying with the visualization and using circles and stuff like that.
It's because and this is because e is a magic number.
E is everywhere, and people don't realize that e's everywhere.
E to the power of x is its own derivative. Its slope at every point is equal to its value at every point.
Now, I'm going to take something, right? I'm going to take this, what you're saying, and I'm going to just run with where my brain is. By the way, the link is out there for people who want to join us. You're more than welcome to come on in. We've been rambling for ages about this. Something I watched about, it was to do with orbits, right? Now, thinking of orbits of planets, okay? Now, we're talking numbers, and the being able to visualize numbers using circles going backwards. We've now got this on a graph with a circle on it. And as you say, it repeats every time it goes round by pi. You know, covers the circle, repeats itself. And you can visualize that in a number form. You can visualize the number in a graphical form by doing that. Now, here's a thing that our brains can't do. If you then take that, as we say, that circle that's repeating itself, and apply that to an orbit, you have a sun and you have a planet going around it like this. Okay? That, and seeing the pattern in planets when you start to add them, is very, very difficult to do visually. Okay? But what our brains can do really, really simple is if you set a straight line and put a beep of a different tone for every planet, we will be able to remember that musical tone a hell of a lot quicker than we will be able to remember the visual pattern of every time they do a full rotation.
Yeah.
Now, I don't know what point I'm trying to make is. I'm just trying to say going from numbers to visualization helps.
Yeah,
And then going from that starting point of a visualization, you then need a musical point to help.
Yeah,
it's hard how our brains work. It's fucked up how our, like, if I can see, I think I've got the right words now. To visualize, to get numbers right, it's easier to visualize them. But to get a visualization, it's easier to add a musical pattern. There.
I don't have enough experience thinking about numbers musically to agree or disagree on that, unfortunately.
Well, it's not music it's not numbers to music. It's the visualization in the minute. The thing I was making
to audio.
Yeah, if you're looking at planets orbiting a sun, it's hard to remember each sequence of when they pass their full rotation relative to each other. But if you just go beep, 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 and then it becomes a musical tone, everybody can remember music easier than they can remember a visualizing thing that they have to draw.
Yeah, but can they remember which note corresponds to which planet as well? I don't know if I'd be able to remember that.
I don't know.
Because I don't have a very good sense of pitch. Particularly in isolation, I'm not going to be able to tell you which tone is which, unless it's obvious. But compared to most people, it would become non-obvious at a earlier point than it would for others, because I am completely tone deaf.
I think we're now just actually rambling. But I've put the link again in the chat. Come on, people, jump in.
Well,
there's bound to be other people that know physics except for fucking me and Mr. Weasel. Dr. Weasel. Where's Leo? Right?
Where is Leo? Oh, shit. My fucking cushion fell off. Sorry. There we go.
So what is it that you're doing right now? I think we discussed before that you were talking about sensors for gravitational waves. Something.
Yes, I am. My group is building a device that or is part of a collaboration to build a device to perform extremely sensitive graviometry measurements, so measurements of the local acceleration of gravity.
Okay, I'm going to make a simplified version for the people out there in the world, okay, that are watching this. Gravitational waves, which you will go into in a wee minute to describe what they are, okay? They change the shape of space and time and warp it ever so slightly. And general sensors at the minute is shooting a light beam at a 90-degree angle, and when it comes back, it's a wee bit off, and that's because shit be moved. Okay.
Yeah.
Are you developing a new one of them, a more precise one of them, or something along those lines?
I'm developing one of them.
A lot of lasers. Lots of lasers.
I'm developing one of them where instead of the distance between the two mirrors across that really long light beam that you described, instead of that varying, it's the distance between two clouds of atoms that are falling in a vacuum, and you can probe that distance. You can probe that distance with a laser.
Yes, so the idea of, really simple experiment that we had whenever we were at school, you're given a ruler and the person drops it and you have to grab it. And you can define how far, due to the speed that it's falling, to where it grabs at that point. So if the laser beam is coming back and it doesn't go between that cloud exactly where it should, that's how you're telling. So it's more of a vertical than a horizontal.
Well, it's more. It's
I'm trying to dumb it down
yes.
here.
I know. The problem is the reason it's incredibly effective at measuring these things is because clocks have their own internal clock. I mean, atoms have their own internal clock. Sorry,
Would
and
that be the decay rate?
it's related to the decay rate. It's related to that. And so when you hit them with a laser, you kind of start this clock ticking because you've put them into another state that takes a while to decay, but they have this own internal clock that's related to the decay rate. And when you take the atoms and you interfere them with themselves, you split them apart and you put them back together again as though they are waves, because they are waves, then you can make a measurement of exactly how long that internal clock was ticking.
Right.
And
this is okay. Keep going. No, I have a question.
And you do that at this end and this end, and it tells you exactly when this cloud was hit by a laser, and exactly when this cloud was hit by a laser.
Right.
You know exactly when that happened, which means you know exactly how much distance there is between them. Yada yada yada, measurement error and stuff. But that's the idea.
Right. I'm gonna ask the physicist who works with lasers every goddamn day. Only 6, by the way. We need to start a GoFundMe to get them at least 10 lasers, right? What is the speed of light?
It's 1c.
Okay, I'm not asking for an exact number, right? But you're going to say 2.3 times 10.
It's 2.99. I don't remember the rest of them. I think it ends with a 2 or an 8.
23 or something. Isn't it?
Yeah, it's roughly 3 times 10 to the 8 meters per second.
Right. Now, I'm gonna ask you another question.
Is it how long is a second? I know the answer.
No. Oh, I know. No. That's I actually watched that like less than a week ago with a new definition of a second. Right. But anyway, I had this conversation with a person quite recently who never caught on to this, who didn't realize this, and who never thought about this before. And I don't know if you have or have not, or probably because of the conversation that you just had, may be able to disprove me or contradict what I'm stating. The speed of light, right, cannot be measured in a one-way system. The speed of light can only be measured in a return system, because if you start the clocks and you move them away from each other and all of this physical bullshit that you know about, it causes issues. So the speed of light as measured is 2c over 2.
Yes. That is as I spent like a solid 4 hours in a Wikipedia hole, and online interneting, and I'm good at Googling, and I know physics, so I know when I'm seeing something that makes sense. And this is strictly and formally true, and it's maddening. It's maddening because it's so easy to think of like a trillion experiments because if the speed of light is going in one direction, then that means that thermalization of large systems can only happen in that direction, which would have consequences for observables after you measure a thing. How is it that when a supernova does the thing, it doesn't do it? But if you do the math,
see, okay, so you do know of this. Okay, we've confirmed.
And it's maddening, but it's true, and but it also...
It broke his brain.
It breaks everybody's brains, because the thing about it is by knowing that is true, you also know that it doesn't seem to matter.
No.
Because it's not observable. It's not a thing that physically exists.
It technically doesn't matter, yes. But I think a very good example that someone used was using conversation between here and Mars. Speed of light conversation, between here and Mars. I think that was the example they used, and I can't remember...
If you could break the rule, then it would matter.
No, it still works. This is the example that they used. That no matter...
Then they're wrong. then if they've developed a way that reality would be like different,
No,
measurably
it was a
different.
thought experiment based on this topic of conversation that we're talking about. As you have said, if it works one speed one way and double the other speed that way or whatever, it still works regardless of the fact that it's 2c over 2. This was the example they were using, and to show this, even if it is, say, twice this speed that it is this way, it still works. It's still the way reality is.
Yeah, and also exactly, it doesn't. It works, and by works specifically, I mean that it doesn't have any. You can choose. There are probably mathematical constraints on exactly how you can choose it to some. I mean, it has to be like you can't. Infinite is a limit in sort of one thing. Oh,
either a stream just ended or people like to break their own brains because it's just jumped by about 7 people when we started about talking about 2c over 2.
I was about to say.
I like permanently changing my brain. Peace and respect.
Well, no, because my new boss just spent like we had like a 45-minute conversation on how it is essentially important that the speed of light is a finite number, because there was a thing he was showing me in a paper where like that matters a lot, and I'm gonna have to think about that. That's interesting. I wonder if that's actually interesting. That might be actually interesting though. Sorry. But because it can't
Right, the link's pinned for anyone who can come in and prove that the speed of light is a confirmed thing.
that the one-way speed of light is well defined.
That the one-way speed of light is well defined. Come and prove me wrong that the speed of light is not 2c over 2.
Yeah. Yeah, because the immediate loop you get into is, oh, well, then you could do this, and it's like, no, you couldn't.
No, you can't.
Otherwise, that would be a measurement. Anything you describe where reality would like be different in the two cases.
Well, you see, that's where I see the correlation between yours and the fact that it's so goddamn defined. Now, I know if there's an error, there's an error, and you still have to go back to the two-way system.
Yeah.
No matter if the error is basically negligible, the fact that it's there means you have to go back to the 2c over 2. But your system that you're describing is not something that I've ever thought of before. Obviously, I'm not in the field, but yeah, I like your experiment for gravitational waves. Could it be tweaked in your mindset to check the one-way system speed of light?
I think it might be that it could. It might be a way of formally ruling out.
Okay, I'm gonna ask a question.
Hold on. Of formally ruling out an infinite speed. But then you would still have. It could still be different in different directions, but it couldn't be infinite in one direction, and that'd still be interesting. And I don't know if the argument extends to that degree.
Okay,
actually,
I have a question.
It's a subtle point.
Right. Here's my monkey fucking moment, right?
Yeah.
Agree with me or disagree with me on these statements, premises, or whatever I'm going to put forth, okay? First premise. 2 atoms can be spooky action at a distance. We can instigate that, and we can, what do you call that? Quantum entangle. We can get 2 atoms to be quantum entangled. Yes?
Yes.
Okay. At no matter what distance they are apart, these quantum entangled atoms will do their flippiness at the same time.
They don't. No.
Okay, I'm being very vague. We do measure that these things change their position relative to each other at the same time. Is that a better way of stating it?
You know what the other measurement. A measurement of one is a measurement of the other, but.
Fuck me! You said the magic word. You said measure. Oh, we got the history of science. Oh,
yeah, it's. I mean.
Right, here's a question. I'm going to really simplify it. Forget about the premises. I'm just going to say it. Okay. We have two atoms that we have super entangled. We have separated them. That we can tell that what happens to this one happens at this one. Sorry, what happens at this one, the opposite happens at this one. But the point is, it's at the exact same moment in time. Can we use light to instigate a flip in this one and set the light source here? So if we had the light source here and we knew what was happening, when it flipped this one and caused the original measurement, can we then measure that one? I don't know. Like, I'm going somewhere with this.
No. The answer is no. The answer to that is no. You can't use it to actually. You cannot use it to transmit information. And in this case, information is well defined. I don't know the definition off the top of my head though.
Yeah, information. Black.
Haven't they done that though? I've seen something from physics.org that in other places that they actually did use quantum entanglement to transfer information from one atom to the other. I mean, it's a far cry from teleporters, obviously, but
no, not to transmit information. No, that's. I'm pretty confident that that's.
Information is a word that we would use as an information you would conflate with data. Information technically is not data.
Now, information could be if you could transmit information, you could transmit data. Okay.
Yes,
but
all data is information, but not all information is data.
You can't do a thing and have something else here happen before a hypothetical photon traveling straight in that direction at the speed of light would get there.
That's the thing, because of the time factor is taken out of it. But then to take the time factor out of it, you need to confirm the first point where the light source came
because the
from.
thing is, the thing about entanglement is you have a system like this, and when you measure it, it's either up or down, right? So if you measure it and it's up, then this one's going to measure down when the other guy measures it.
Right. Well,
maybe he measured it first, and it was down, and now yours is up
at
because
the
of that.
exact same time. Okay, we're gonna.
Here's the thing. How do you transmit something? Tell me what to do.
Okay, I'm gonna tell you. Right, you just asked me. Right. So I've measured this motherfucker, and this motherfucker is up. Okay.
Okay. Yeah, it's up.
Right. This is also where. Okay. This.
Yeah.
I don't know. Right. We're all doing this. I can't. Okay. This motherfucker.
Yeah.
This is also where the light source is. We know that this bio's down.
Yeah.
Right.
But he knows that you're.
Dude, you asked me to answer you. You asked me to answer you. Right. We know this boy's up, and this boy's comfortable sitting up. This boy, girl, Adam, or whatever they are. They're comfortable sitting up. They're going to stay like that.
Yep.
We then put a light source right here. And the moment that we have measured this boy is up, we've also shoot a light source out. So we know this bio was down. This light source then hits him and causes us to detect a measurement. At that moment that we take that measurement, can we cause him to go up? And then we would be able to measure the difference in time. Because time, I know no.
But my point is,
Tell me why I'm wrong.
Well, what information got there first? You can't, tell me how a signal is being sent. Do you know that you're going to measure up?
This boy is going, no, I'm using up as an example. Right, so we use a light source. Hits him, and the moment we get that measurement, it then shoots off towards the other bio.
Yes.
Right. So we've got the measurement from him either up or down. We were using up as an example. Okay?
Yes.
It then will go across to the other fella and bounce off him, and then we can take a measurement off that using the same photon.
Yeah, okay, yes.
Thinking a game of pool. Boing, boing, trick shot.
Yes.
Right? The difference between these two has been negated because time is gone because they're super entangled. So we now know when this guy is up.
Yeah.
right? When it then goes across and hits the other fella, we knew without measuring that he was down, but by hitting him, we then cause him to go up.
Okay.
We can then measure that time that it took for that light to go from there to there and the distance traveled.
How are you going to measure that time? It may sound like a stupid question, but you didn't actually include anything that tells you the time.
I knew from my statement that before I started that I was wrong, and I was asking you to tell me why I'm wrong.
Because it's unclear what you're trying to do. What are you trying to send information? Because you haven't sent it. What information was sent?
There was no
the
information
knowledge that this
sent.
guy was up.
We knew. I have
the knowledge that this guy was. Information doesn't mean you know something about what's going to happen over here. It means they know about what happened over here before light could get there.
Am I mathing? I'm
no,
trying
you're
to math.
Sideways. You're this. Get it right. Come on. There you go.
The idea.
There it was.
Here's an analogy. Here's an analogy that I think is helpful in this. If you imagine a ship flying in front of Earth at like, hold on.
Ludicrous speed.
So
hold on.
shadow can move faster than light. A shadow can move faster than light.
Let's just stop for a second, right? Take a deep breath. Say, welcome Richard that hasn't said a goddamn thing. Welcome Michael that hasn't said a goddamn thing except God.
Sorry.
And welcome Bree. Thursday, 1 week. It's a week in Thursday till I get some hugs.
Oh, sweet. I'm so excited. Oh.
So, Michael, thoughts on what's been happening and talking? I know you're generally busy for the first hour that I stream. I don't know if you've had the chance to listen.
We can't hear you.
And you're muted. Hit your button.
Unfortunately not. I popped in the chat to say hey, but I have not listened to anything. I just came in with you asking a question and the thumbs up, thumbs down. So if you just give me a brief recap and also you don't.
Okay, a brief recap. Just before
I know we've met before, but
just before you come into the chat, or just before you come into the panel, I made the challenge to the chat, which you looked like you were standing up to and ready to fight, was come and disprove that the speed of light is defined technically as 2c over 2. Because the reason I say this is the speed of light cannot be measured in a one-way system. It must be measured in a reflective nature. You can only measure the time it took to get to somewhere and back again and divide it by 2 to get the speed of light. And we are discussing the possibilities or the non-possibilities of figuring out equals c. Nothing ever equals c. It always equals 2c over 2.
Do we always infer that it's going the same speed going out as it is coming back?
This is the conversation we're having. Clearly you haven't been watching either. Thank you everybody in the panel for not
I don't
caring.
I don't do math. I do science, so I guess I do math, but still, I do applied math.
The answer to your question is yes. Basically, we do assume that. We assume that, but in our reasoning and stuff, it turns out that, like, I guess no measurement would be different. You can't tell a difference between these two things. If it's going if it's going half as fast that way and almost infinitely fast, this way, turns out you can't tell the difference, and it's maddening. It's maddening.
Yeah, it doesn't matter whether it's this way or that way or the other. It technically doesn't matter.
And this, like, I convinced myself that it's not something I, like, knew a whole lot about, but physicists know this. It's like a thing that physicists, like, showed because somebody did some math one time. It was like, well, technically, if you think about the nature of measurements and the concept of locality, this could also be true. And Einstein pointed it out, I think. He was like, yeah, special relativity works either way.
Okay, well, here's the thing that we mentioned just before we come on stream, right? You just said measurements, okay? If I asked you to measure how tall it was, how tall it was from the floor of your room to the top of your room. Give me an arbitrary answer.
And well, what do you mean arbitrary answer?
It's
Give me an accurate
approximately
Oh,
2
approximately.
meters.
Okay. Yeah, I mean, it's
Like, I literally don't care
12
what
feet.
your answer is. You could say
It's like
2
12 feet.
centimeters and I'd still take your answer.
It's like 12 feet.
Okay. And what do you weigh? Approximately. Not approximately. Make it up. I don't care.
100 kilograms.
He goes by Dr. Weasel. Okay? Dr. Weasel. The point of this is, when you make a measurement of something, there is a definitive thing at the end that defines what it is. It is 12 foot. It is 100 kilos. It is X, Y, and Z, meters, centimeters, this, that, and the other. There is a few numbers out there which can be proven to exist and have mathematical properties that can be applied in equations that have literally no measurements, as in no measurmental unit. No unit. That's the word I'm looking for.
Unit.
No unit. What are they known as, or can you give me an example?
You do not look like you weigh 100 kilograms. I'm just going to throw that out there right now.
He's got fat legs. You should see him when he bends over.
He's really tall.
Yeah, I am. I'm 6'4", and I weigh, with this headphone, I'm weighing, hold on, 235 pounds. So I think that's a little over 100 kilograms. Yeah.
No, it's like that's, yeah, I guess that would be over 100 kilograms. Geez.
Yeah, I think 100 kilograms is about, I think it's 2.2 to a pound. But yes, both of those have dimensions of mass in this case. Pound is weird because
distracting
pound
him,
also
Michael.
is the unit of force. These are the dimensions, though, is mass. The units are pounds and kilograms. These numbers that have physical significance in equations, but don't have units, are called dimensionless constants. And they're called that because when you set them equal to each other, they just don't. They don't have, all of the units drop out. It's like 1 second divided by 1 minute is 1/60th. There's no more units there. It's 1/60th because they both have units of time, and you can transform the minute into 60 seconds, and then it's 1 second over 60 seconds. The fine structure constant.
Fine structure constant. Thank you.
Yeah, which I'm looking up to remember exactly how it normally is, because yeah, in normal standard international units, so normal metric units, the fine structure constant is the electric charge on an electron squared over the reduced Planck's constant times c. So it's E squared over hc, or h bar c, where E is the electron's charge. And it doesn't matter what you measure that in, because if you re-express those numbers in terms of each other, all of the units drop out, and it's equal to about 1 over 137. And that matters, because if it was equal to 1 over 139, like, stars couldn't form or something.
Or something. You sound, yeah, you did get your PhD the same place as Kent over.
I didn't. I'm an experimentalist. I spent the last 2 years of my PhD alone in the laboratory during COVID, trying to get my very complicated machine with a bunch of different lasers, although apparently not enough to impress MathPig.
No. Here's a question, right? Here's a question. Okay, I'm going to interrupt because I am rude and it's my channel. I'm going to break my own rules. But if I don't get my fucking thoughts out, I do have a habit of losing what I'm trying to say. So I'm going to ask. Oh, Leo's here now. I'm going to ask Dr. Weasel what their particular favorite point in physics is and the reasons why. And then I'm going to ask Michael, with his history in the background in the history of science, does he know of what this is? And on the history of significance, the history of science, the significance of that.
Oh, that's tough.
Well, you could just like the fact that they come up with lasers because some cunt burnt a hole in the moon, and Michael can say, well, the history significance of that is nothing. You know, that's what I'm going for.
No, my favorite. Oh God, mine is a personal anecdote
That's exactly what I wanted, and I want Michael to tell me that
it's not my
worth a
personal
shit.
anecdote. It's a personal anecdote from. Oh, this is doxing myself though. I can't. Okay. Other than that, I won't. I don't want to do that because I've doxed myself.
Pick your
sort of on
second
the internet,
best
but I don't
then
wanna
that
do it.
doesn't have your name on it.
Well, fuck. Now I don't know. A good one. I don't know if it's my favorite, but a one that I like would be the discovery of the cosmic microwave background, which was done
Accidentally.
Yeah. And I don't remember the full story behind it.
They were trying to set up a new radio station or something like that, and there was this constant noise in the background that they moved their dish around in multiple different directions. And no matter where they pointed it, this background noise was constantly there. They then give this information into some sort of a headquarters, which passed it on to someone else who were trying to prove that this shit existed, and was like, these motherfuckers found it.
Yeah, and they were like about to turn on their own big microwave horn to try and detect it. Is what I remember. Like they got scooped almost, but it ended up working out. I think. I don't think people like got too robbed, but maybe they did. Maybe people got robbed of Nobel prizes, and I'm wrong. Is that what happened?
Maybe girl's gonna figure out quantum gravity. So yeah, that's cool. I'm gonna see what a Nobel Prize looks like.
I have some favorite Nobel prizes.
Hold on. No. I want to see the significance of the background radiation in the history of science. But we all fucking know that. Could you not tell us the true one, which is shit, so Michael can make fun of you?
Can I ask a sidebar question?
Go.
For our Weasley friend here. Have you ever met anybody in your field who doesn't adhere to a B theory of time?
Honestly, I don't think most people in my field would be able to tell you which was which.
Oh,
it's
really?
A philosophy question.
It's a philosophy question. It's I don't know enough about the subject, and it to be able to tell you. I couldn't discuss it. What are the differences again? One of them is real and the other one is not real. I don't know what that means. It needs to be more well defined. So
I loosely define it as to try to relay it on a. It is the B theory of time is that both space and time are emergent together and tethered, so time and space are intrinsically tethered to one another and move forward and expand at the same rate. The other would be, or in conjunction with the other. I shouldn't say they're at the same rate. They may have variables in the rates, but then the other would be that space and time are that time is linear and space is expanding. Space is expanding.
Yeah, I think most people would hear that and be like, well, one of those respects general relativity and the other one doesn't. So to the extent that's true, I would agree with it. I imagine there's nuance there. I imagine.
Oh yeah, there's a lot of subtlety to it. Absolutely.
Yeah, it's an incredibly subtle question, and as such, I would not feel. I wouldn't. For example, I'm not convinced that transmitting information faster than light is impossible. I'm not convinced of that. I'm just convinced that under our current models, if you accept all of those statements to be true, they all show it's impossible. And so
can I ask a clarifying question before you continue?
But our models are also incompatible. GR and quantum theory are not compatible. Something is wrong. We know something is wrong. And so we don't know what a theory that corrects the things that we know are wrong looks like. It may look like something where you could transmit information faster than light. I don't know.
Leo is in the background, and I don't want to let him in until I ask the question because he will probably take over. Love you, Leo. So I want to ask you a question on the statement that you just made, and then I will let him in. I can let him in now. Okay, we'll let him in.
Where's my questions?
Oh, I give you the floor twice. You got shy. You just sit back.
Hey, Leo, did you see my roast video on you? I totally roasted you.
I'm gonna lose my train of thought. Right.
No, I don't think so.
No, I'm just joking.
The idea
What the fuck is this, dude?
the idea that information can be traveled, or information can be, transported faster than the speed of light. In this universe, we have shown that that's not possible. In this dimension, we have shown that's not possible. So are you saying that the idea of getting access to a loophole, area, subspace, whatever the fuck you want to call it, is possible? And if that is possible, would that constitute a reason for where gravity can leak into and why it is one of the weaker universal forces?
I don't know. I don't know.
Okay, Leo, we're going to interview you now. All right, go. Sorry, Michael, would you like to ask a question? Because he can't.
I mean, I have a lot of questions. Dr. Weasel.
Hi, Michael, can you bring your gain down a wee bit?
Sure.
Not too much.
All right.
No, it's perfect.
Good.
Perfect.
So yeah, I missed the first part of the conversation, so I didn't hear your background, Dr. Weasel. What area?
It's probably for the best.
What area of physics do you specialize in?
I'm currently a postdoc, and I am.
I'm sorry.
I'm an experimentalist in the field of ultra cold atoms specifically. That's sort of the subfield within atomic, molecular, and optical physics. So yeah, and we are developing a experiment that uses atom interferometry to measure gravitational waves in the long run.
Gotcha. What are your thoughts on, in general, physicists like Carlo Rovelli and the idea of kind of quantum gravity as a kind of emergent property of the universe? You think it's all bunk, or
I don't know enough about it.
We can't leave out Juan Maldacena and Leonard Susskind.
I don't know enough about theories of quantum gravity. It's not. Physics is a vast field, and
definitely
during my day job, and during my PhD, I literally never thought about it because I'm thinking about how to measure things like Efimov states, few body quantum systems, and the effects of interactions between atoms at these scales. And it's a very different question. Even it may not sound so different, but it's a fundamentally sort of different question than the quantum gravity. I am working very comfortably within a quantum framework that basically most of the core pieces were kind of set, mathematically at least, by the end of 1926 for what I'm doing, until you need to add QFT, in which case you got to go into the 50s. But I'm not there's so much richness to be done in exploring that, and the people who study fluid dynamics have it even worse because they're studying things. Classical fluid dynamics is still an incredibly fruitful bouquet of questions that are interesting and important and really hard because the Navier-Stokes equations just bend you over and have their way with you, whether you like it or not.
No, I get it. I was just curious. The more higher up in the education you get, the more specialized you get. It makes sense.
I read a book, I think, by Leonard Susskind 10 years ago, but I don't even remember it very well. I think it was the information paradox or one. The one where he had the bet. He was the one who had the bet with Hawking, right?
Leonard Susskind?
Was it him? Was it somebody else?
I have no idea. I thought he had bets with a couple of people.
Well, yeah, maybe, but the big one about black hole information with Stephen Hawking.
I think that might have been with Leonard Susskind. Yeah.
Yeah. He wrote a book about it. I read that book like 15 years ago. God damn, I'm fucking old.
But I wanted to say that I think it should be pointed out, as Weasel kind of has done already, that there's actually quite a stark difference between experimental physics and theoretical physics.
And there's a stark difference between theoretical fundamental physics and what most theoretical physicists do. A lot of theoretical physicists are working within. They're working to see how molecules work. It doesn't matter if string theory is true. It does not matter.
Yeah, foundations of physics is itself a very narrow area within theoretical physics.
And it happens to, yes, exactly. It's the most controversial, I would say, and kind of obvious one that people think about. So it's understandable, yeah. And it's what most people, I think, it's how most people, I think, get into physics. Is sort of the ability to more and more generalize and have sort of a bigger high level understanding rather than focusing on how something works. Like if you're always people who are rebuilding their TVs at home aren't necessarily gonna become physicists. People who go around with a magnet and just poke it against everything, I think, are more likely to become physicists, even if they have no idea how to fix the TV that they broke with their magnet.
Right. There's an exact example of this, right? I have at work we have a fucking palette, man, right? If you could get a camera that would show magnetic waves, we have a fucking palette that's 2 foot deep of just aerodynamic, like giant ass magnets that we use for like stuff at work, for whatever. And these are that cool that I couldn't not slightly borrow one and take it home. And I can connect it to the underneath my wee girl's bunk beds, and she can hang off it. It's like really strong, right? And I had it in the top drawer of the living room for months. Fine, it's fun, talk at home. Stools now here and all the rest of it. And I moved my computer system into the living room. I pay for 900 download and 100 upload. And I come to the living room, set up the Wi-Fi, which is generally very, very good. Good boxes and, hotspots. And I'm getting 40. And I'm spending a week getting real pissed off at the fact that I have no fucking Wi-Fi. Before I fucking remember that this giant ass magnet is sitting in the top drawer 3 foot from the fucking Wi-Fi box that I'm using to connect to the fucking internet. And you move the magnet away, and I put it in the kitchen now on top of the cupboards, and I'm back to my normal speed. But as you say, people trying to figure out how to fix their TV and stuff like that. As soon as I seen the magnet, it was like, that's what it is.
That's interesting. It's not obvious to me that the magnet should cause that problem.
Is it
it's
not?
A DC magnetic field. No, not really. Not like immediately obvious. I don't know how the various receivers and stuff actually work, but
that's
most
more
of
of an engineering thing.
It's not gonna distort the signal. If the signal's being emitted and the signal can be received, having a magnet in between isn't gonna mess with it. So
not directly, but it creates a fuzzy zone.
Yeah, it must mess with how the thing works. Like if it's an antenna could get messed up because an antenna relies on rapid current, and if you have a magnetic field, that can
my computer is directly wired into a Wi-Fi hotspot box. So it is directly wired, but it's that Wi-Fi hotspot box that gets a Wi-Fi signal, So it was that was being interfered. It was literally like 2 foot from the fucking magnet. And the magnet...
I remember this happening, and now I am inclined to laugh.
The people in my tech zone that know me are like, yeah, sure, like, there's a magnet, fucking dick, we've been working on this for, we tried everything, man. Like, everything. It's what started me down the route of rebuilding my computer. And on a personal note, check the Twitter. If anyone hasn't seen the Twitter,
Your computer's beautiful.
I modded a 12. That's why we didn't do the Tuesday show, Richard. I got hold of a 12-year-old full ATX case and modded it, and a few extra fans and stuff, and ripped the side of it off, painted an entire perspex side, added LED remote control lights and shit. Spent a total of £15, people. So this shit can be done for very low budget. But now I'm rambling.
Dr. Weasel, I sent you a DM just when you get a chance. Yeah.
So, Michael, what is your favorite point or most poignant point that you would say? And if you answer the fucking Einstein-Bergen debate, right, apart from that, what do you feel is the most poignant part in the history of physics individually that has spurred and where we are right now?
I mean, that's
E equals
impossible.
MC square out the window. Fucking Einstein, Bernstein out the window. Come on, none of these obvious answers. Give us an anecdote. Give us something personal.
Well, if you want to not, sorry, I have an obvious answer.
Oh no, ask the no. Let the physicist redefine my question in a better way. Go.
No, I wasn't gonna say to redefine it. I think it's well defined. I think that a non-obvious answer to the question, though, one that everybody here has, I would imagine, heard of, but isn't as well known, would be Noether's theorem. I think Noether's theorem is not known by the general public, and I think
give us a description
fundamentally. So Noether's theorem is it's a statement in functional calculus, which is calculus where you're playing with functions instead of numbers. And if you have a symmetry, if you in space, and like it's a mathematical result with physical implications. If you have a symmetry, then you have a conserved quantity that is associated with that. Because things are the same over here as they are over here, that's why you have conservation of momentum. Because things are the same now as they were 5 seconds ago, that's why mass energy is conserved. And because things are the same if you rotate them, that's why angular momentum is conserved. And that's pretty cool.
And everybody in the world, well,
it's really cool.
I take that back. That's a very broad brush. A lot of people know this statement: energy cannot be destroyed or created; it can only be. And that's a general sort of thing that's out there. So I would agree with you that a lot of people know that without knowing that.
Yeah, you can.
Leo, if you're gonna say because we're boring you, fucking mute.
I didn't fucking sigh. I'm reading shit on my phone, dude.
I'm winding you up.
I would say, I mean, I think that's a interesting answer that I've never thought of before, but I know nothing about the history of physics after 1945 because that's where my knowledge stops, is with the Second World War. But one of the lesser known, but probably one of the most important players as an actor, not players in like pimp or anything like that. I got a code switch a little bit there. One of the most important lesser known figures in World War II that I think super interesting is a physicist named Leo Szilard, who was one of the, you have I'll try not to get too bogged down here, but you have the flight of physicists out of Germany in the 30s, especially because most of them were Jewish, right? And we all know what was happening in Germany in the 30s. There's a fantastic book called The Men from Mars that talks about the kind of like intellectual migration out of Germany in the 30s by the people who were financially able to get out. But Szilard he came up with the equation for the nuclear chain reaction, and probably more importantly, when it's presented, it's often presented like Einstein petitioned Roosevelt to start the Manhattan Project, but it was really Szilard. It's just Szilard knew that he needed a bigger name, and so that's why he tracked down Einstein and got Einstein to write the letter. but it was Zillard that was kind of orchestrating all of it from the shadows, and it's Zillard that helped set up the Manhattan Project until Oppenheimer took over. But yeah, that's important for probably different reasons. The fact that, nuclear weapons, I don't know.
Yeah, I think it was like a series of like 5 letters. I actually I did a project on them in like 6th grade.
So what you're telling me, Michael, is Zillard was the Antichrist, and I just need to accept that. Yeah.
Well, yeah. This is a really interesting time period, and he's not the end. I mean, anyway, it's an interesting time period just because it's the meeting of science and ethics and politics all boiled into one gigantic project. But yeah, he deeply regretted the decisions that he made, as did most of the scientists that worked on the Manhattan Project. But yeah.
Michael, you may or may not find it interesting that I'm right now broadcasting from the room where the Trotsky assassination plot was hatched.
What?
That is
Really?
interesting.
Pretty cool.
Excuse me, a baking powder? What did you just say?
They know what I said. What I said was the Russian turncoat Trotsky was hunted down and murdered for selling secrets to the United States, and I am in the bottom of Zook's pharmacy.
That's pretty cool.
That is.
I did not know that, Richard. That's pretty neat.
Are you trespassing, Richard?
Richard
I
works
actually
in
have permission to be here.
I would imagine.
Richard works in construction rebuilding things, so it is logical that Richard could possibly be there. I would worry about the person who's employing Richard more so than why Richard's there.
I mean, I'm employed somehow.
If anybody here is really or anybody in the side chat's really crazy about that idea, I can send you wood that still has creosote stains from the old coal burning stove.
Bring that with you. Again, mentioned Mathminopalooza happening in a few weeks. I will be in America in less than fucking 2 weeks. So there is 2 slots still available. 70 quid tickets. That's accommodation. That's food for 2 days. That's your museum. That's the t-shirts have arrived. I've seen the t-shirts. They're looking really good. So all that stuff there if anyone wants to.
Monkey thought. What if everyone brought something from their own little hometown and their own little thing for everybody?
Oh, where is it? It's here. This is branch from the tree of the garden that grows in my back garden, and I have started to imprint it and burn it in with people's names and stuff, so everybody will have a wooden key ring that comes there. But you've just ruined my surprise.
You're already doing that, you sneak. What do you think of the idea? What if everyone brought something?
Well, I think it's that good that I didn't tell anyone because I wanted to be fantastic, but now you want everyone to be the same as me, and I'm not going to be the best, so...
So sorry.
We all want a lock of your beard, Richard. You should get 6 to 10 key rings. Then ones that you can pop the front off. Take a wee
Trim not even the corners of your beard. Trim not even the corners of your beard. It's a law. Sorry.
Get one of
You
those,
don't trim at all.
Christmas balls and stuff Richard beard hair in there.
I could put LED lights in and a battery behind my ear, no problem. But you can't have any of it. That's just how it goes.
If I can just have 2 seconds, Carl, I've no idea what you mean by the blue box. I've no idea what that message, that comment that you left him. I was genuinely dumbfounded, sideswiped, have no idea. I have no problem with anything that you have said to me or any of that about Elena or anything like that. I love that you come here, Carl. I think it's funny that, the whole must type as Carl, that's no problem with you, Carl. Love the bones of you for being here, so... I'm sorry if what I said offended you. I don't know what it did. I didn't mean it that way. Just quicker than typing. I was trying to type. It's quicker to do that. So Richard, you're bringing a part of your beard. You don't shave your beard whatsoever?
Okay, first of all, it's kind of gross to give away human hair or accept it. That's kind of weirding me out. That's the first thing.
Put it in the
How am
keyring. I don't
supposed
have to
grow
touch
my
it.
own mats, and if I don't, you don't even think about
What-
other people, do you?
What do you use in your polyjuice potion?
Right. It just seems like you're being selfish with it at this point.
I always
Killing
make
me,
sure.
Bree.
I always make sure.
I'll save everybody some if that's what they want. I mean, they naturally, the follicle will let go when the hair is at a certain length. I don't have to trim it. I mean, hairs come out all the
just
time.
get the little
You see-
basket for your drain, and
Okay.
You're gonna
I'll
have one of
save them
these
up.
now.
This is so odd.
do not
Dr.
do that.
Tapioca,
Do not.
Dr. Weasel will have one of these in a few years because you get really attached to your ponytail, and when your forehead becomes a 5 head and a 6 head, and then everyone tells you you're fucking bald, but you've got hair behind your head, you will cut it off and put it in a frame too. You will. You will.
You framed your ponytail?
He did.
This is right. Now hold
I've got
on.
a pony-
Okay. This is my very last haircut that I ever got. Okay? And down in here, which you can't see, is my wee girl's very first haircut that she ever got.
Aw. What a sentimental guy.
But yes, I had that ponytail for 20 motherfucking years. I put it in a frame as a joke. Everybody thought I was weird, so I was like, fuck you all, I'm fucking keeping it. Then I had a daughter. She had her first haircut, so it's down in there as well. So it's my last,
Yo.
her first.
Yo, if her classmates ever find out about that, they're gonna make fun of her.
I don't give a shit. I am one of those parents that will deliberately go out of the way to embarrass my child.
Do it. You gotta do it.
Causes her to build character.
It's the perfect thing. You just show up and be like, I'm her dad, okay? I'm her dad. I shamed my ponytail.
She doesn't, like, we had this conversation a couple of weeks ago. She doesn't ever know of me. Now, she was born, after I cut my hair, right? But she was a baby, So she doesn't remember me ever having her, and she does not ever think of me with that. She's like, no, Daddy, you're not allowed to shave. Like, I showed her pictures, she's like, who's that? That's your dad. Nope. Don't even get me started. She's really not well at the minute. She's coughing and vomiting her in. She's in quarantine at the minute. I've done like fucking 4 hours of a fucking journey today to just go and snuggle on the sofa. She refused to watch Small Soldiers with me, which I was very annoyed with. That was my entire plan, was to go and snuggle and watch Small Soldiers. And
How is she gonna know about the plight of the Gorgonites if she doesn't watch Small Soldiers with you?
Right. Now, she watched some YouTube thing, okay? On YouTube Kids, okay? Now, I know I'm rambling and this is totally off
weird.
topic. No, pardon?
YouTube Kids is weird. There's some weird shit on YouTube Kids.
Okay.
It's crazy.
Now, she said to me, we'd finished playing. I wanted to play the Tickle and Lena game. She wanted to play hide and seek. Then we did both. And then she wanted to do her thing on her tablet. And she was like, you do watch your thing. Because I was texting Red or whatever. And it was, do your thing, Daddy. I'll do mine. We'll get back to you. Anyway, I looked over. And there's the big screen with a small camera feed. In the bottom corner, like a gaming stream or whatever. The main person. And she's commenting on what's happening. Now, she's the only thing that I thought was, what do you call fucking the Joker's girlfriend?
Harley Quinn.
Harley Quinn?
Harley Quinn. Think of a child-friendly version of Harley Quinn. Okay? Same sort of haircut, makeup, up and down into the camera, very hyperactive and stuff. And they're watching on the main screen another kid's channel where there's these stuffed letters. They're like people, like the A is an A, but it's got eyes and stuff. And this guy starts cutting them open with a pretend saw, and there's tomato sauce in it, and his hands is red, like blood and stuff.
Oh.
And they're pulling things inside, like from inside. And I'm sitting watching this going, what the absolute fuck is
Are
going on?
the letters in pain?
Oh,
Are they
my.
screaming?
No, these were stuffed animals, stuffed letters on a wall with
Oh.
eyes and stuff that they were cutting open with a pretend saw, and this guy was pulling stuff out and then stretching their fluff apart, and it was slime and like. She had a problem with me showing her Assassin's Creed whenever we were jumping from building to building, and she interacted with 2 guys where she had a fight. I don't like the fact that you play this with Elena. And then gives her access to YouTube Kids, which has this shit happen.
Was the slime red? You said it was like
Yes!
tomato sauce, or was it slime?
His hand was literally covered and dyed in red after like the third, I say animal, the third letter he'd cut apart. And he was there like, ha 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 ha. And she's just going, oh look, another letter B hidden inside another letter Z. It was...
Yeah, that's weird.
No.
Like, I have no problem with my wee girl, and I think that my wee girl perfectly, I don't want to say perfectly, that's a bad definition. I think my wee girl, for an understanding of 5, has had the experience of 2 pets dying and her grandfather, so she has a good experience of death. Her grandfather went to the hospital because he was very sick, and he'd been doing that for about 6 months before he passed away. And that weekend that he passed away, she wasn't there, she was with me. And I said to her in the car, going up the road, excuse me, you know that Granda's in the hospital, you know, sometimes people don't come out of the hospital. Oh no, Granda's not coming out of the hospital. This is like the 3rd or 4th time he's done it. No, Granda's not coming back. Granda's very sick, Danny. I was trying to comfort me. You know, she has a good understanding of it. But I still have an issue with a guy in a blue baseball cap and a kid's version of Harley Quinn doing a twisted saw the fucking lady in half thing. It's just...
It's weird.
In human body language observations, they have something they call fading facts, and that's where you kind of back away, the guilty party will like kind of back away from fully admitting, like they'll call the victim it, things like that, where they don't really process it as human being, and this, it just looks like too much of the reverse process. It's like disassociative justification of what is something that is obviously horrific.
Yes, the disassociation of it. I want more an understanding of it, as I said, with the pets and stuff like that. There's a love, there's an attachment, you know, you get that. I don't want the dehumanization, the disassociation. Elena considers anybody she becomes more than close friends with cousins. I have asked her to define cousins because she talked about people who she's went to with parties at school that do, what do you call them, get-togethers at their parents' house, you know, hangouts, play dates, you know. She calls them cousins, and I'm like, you understand that, we'll call her Lucy, right? You understand that Lucy's not your cousin? No, well, I tell Lucy this, the same as my Jenna and Jessica, who are her cousins, you know. I tell her this, we hang out, we do the same things, they come over, they're my cousins. She sees them all as family, as cousins, you know, they're not friends. And I don't want her to learn this disassociation that certain things and certain people can be taken away from, you know. I think it was like 3 Christmases ago, I asked her, go pick a doll. She had the entire doll section. She went and picked a black doll. Colored doll. And whenever we opened it on Christmas Day in front of my granny actually took me to the side and asked me, why did you buy her a colored doll? And I was like, I asked her to pick a doll. She picked a doll. It's a fucking doll. She doesn't see color. She doesn't see any of this, you know. And I don't want these sort of things. It's like, oh, there's a letter we don't like and we want to see what's inside it. Let's cut it open with a fucking saw.
Did you write down the name of the channel and report it? I mean, this is just odd, at least.
Oh,
I did not.
There's weird stuff on kids' YouTube.
So, was this supposed to be like educational though? Are we doing like alphabet learning?
I have no idea. I was doing my thing for 5 minutes on my phone, and she wasn't well. I lay down on the sofa, and she lay down on top of me, and she was like, you want to watch your thing, Daddy, or do you want to watch my thing? And I was like, I'll have a look at what you're watching. And it was like, this is wild fucked up. And to be desperately honest, it was the Amazon Fire Stick or the Amazon tablet shit. And I really can't deal with the Amazon operating system at all. Michael, away.
Yeah, I got to head out. Appreciate it.
Love you.
Night,
See you later.
Peace.
Good talking to you.
It was very difficult for me to try and figure out the way. She has never closed a tab in her in this. It's her granny's laptop that she's been given, and she has never closed a tab in it. So when she just opens, it's very, you go through. It was very overwhelming for me. I tried to close them all except that one. She then got bored, took the laptop off me. It then died. It went to charge. It was a thing, but there was a million tabs open. It was like a flat earther met a flat earther and had 6 flat earther kids, and they all used the same computer. So many tabs. But it's something I will talk to her mother about. But it was. I'm rambling now. Someone else talks.
No, I get you. That's to keep the computer healthy. You gotta close the tabs out, or else you're just keeping all that stuff running all at once.
I did give her access. I opened it up now. I have 2 Dolly 2 accounts, and I give her access to one of them so she could type in anything that she wants, because we're doing spelling at the moment and things like that. And she wanted a unicorn dances with a bear, and then the second was a unicorn dances with her. And rather than you can't type in a unicorn dances with Elena, I typed in a unicorn dances with a small ginger girl, and oh no, it was a Pikachu. That's what it was. A Pikachu dances with a small ginger girl. Came out perfectly. It's now the background. That's about the limit of my abilities with an Amazon tablet. They're shit. They need just wiped and put Android on. But someone help me here. I don't know. I'm being a daddy, and I miss my daughter. I love.
Oh, I miss my daughter too. I get it. Oh, my son's actually into Pokemon though, so he's really into Pikachu as well. Sometimes I worry that this generation is going to grow up to not understand what evolution means because of Pokemon. But you know what? My generation, we grew up with Pokemon. It came out when I was like 11. So.
Yeah, I was born in 91.
So you're a Pokemon generation,
wow.
then. Yeah.
That's not.
Me and Robbie are about almost 10 years older than you.
I took a computer home that I found at a back. I was building my own case before this one out of cardboard and perspex and stuff before I got this one for free. But point of the story is I was searching for just the back of a computer. I needed that backboard to put in, to make sure everything lines up perfectly. And the manager of the store said to me, there's an old computer lying way up in the back of the fucking way. And I was like, right. It was Millennium Bug compliant. I have it on the desk at work, and I asked the guy that I work with, and he's like, oh yeah, I was born 2004. I was like, okay, this computer is technically fucking 5 years older than you, man.
At least.
At least.
Oh no, it was 1998. It was 1998 stickered on the memory.
When did
which is only all of 2 gig. It's 2 sticks and 2 gig. Right.
When did that scare start for Y2K? That started like 97, right? That's when we started.
Yeah.
It was last checked in 2000. Someone's put a tested sticker on it in 2000.
Mm-hmm. Make sure that it made it through okay. Made it through that big guy.
Yeah.
I don't even think Leo was born in the 20th century, were you?
Yes.
What year were you born?
95.
95. Oh, you're older than I was thinking.
Oh,
he's not that much younger than me. He's a little younger, but he's not that much younger than me.
You see, this is the thing. Leo uses better moisturizer than you. You spent all your money in your gaming chair. Leo has an awful setup, but he looks well. So.
You haven't felt my hands, okay? I have notably soft hands. People comment on how soft my hands are.
How many people do you walk up to and rub the face of? All right, you should stop.
No,
doing
it's after handshakes, bro. I'm not.
Can I ask you guys, is being born in the 90s, what's the first? This is a little bit off topic, but I'm just curious. What's the first video games that you all remember playing?
The first video games I remember, but I didn't play because I wasn't old enough, was the Nintendo 64, and
yeah.
I want to say I don't know if it was a PlayStation or if it was some Sony system.
I want to answer too. Atari Pong.
Okay, I'm Commodore Amiga 64 with a tape deck stuffed in a wee back room in my ma's house that you'd have to fucking hit the button, go eat your dinner, have your dessert, and come back up again. And you're playing Paperboy or Road Rash in 2D on a tape deck load.
Yeah, for me it's probably Game Boy, and we had it. It was the original Game Boy, the
Yeah.
big bulky one.
The one that
we had.
turned yellow after about 3 years.
I asked
Yeah.
my mother for a Sega Game Gear. Do you remember Sega Game Gear?
No, what
Yes.
the hell is that?
Okay,
They
right now
ran
I'm
through-
talking to Bree. I'm only talking to Bree.
I remember it too.
Ran through batteries, so because it didn't have a charging thing, it ran through
Right.
batteries like then. Yeah, I remember it.
I asked my mum for a Sega Game Gear because I didn't want this Nintendo Game Boy. I don't want to be mainstream. I've always been wanting the outsider, right? So give me the Sega Game Gear. And my mum went out and my mum bought a Barcode Battler, which had the same form as in, Sega Game Gear, but it had one game built in, and it was a 2D fighting game where it was just two characters that would, punch and kick and shit. Their stats were built off reading a barcode. And the whole gimmick of the thing was you could get a Kellogg's box and cut the barcode off the back of it and scan it and end up with this unbeatable, amazing character that nobody could destroy. So I'm like running around for like 6 months cutting barcodes off every goddamn thing, which is why another reason subconsciously my last 3 passwords that I use, my passwords before they get figured, I'll just go and if I need a new password, I go to the breakfast bar and I pick the Kellogg's box or the cereal box and I read the numbers off the back. I don't want to be picked. I'm not going to use God or MathPig 1. I just go to and I read a barcode number and it's the first 6 or 8 digits off the bottom, and that's how I add them numbers to my bar. But that's from the Barcode Battler. Didn't get no Sega Game Gear. We be poor kids. We could get in Kellogg's boxes and Barcode.
I didn't get any handheld game system. We just had to share we had a Nintendo and a
it
Genesis.
It wasn't a great.
We actually had an Intellivision when I was really little, but I don't remember. I just remember my dad playing it, but I never played it. It's a really archaic game system with cards you slide in and into the control.
Hold on. I'm being shouted at because I'm wrong. According to Dargendorp, no 1998 computer had 2 gigs of RAM. Give me one second. It's right beside me.
That sounded like a lot, but
I have to say,
Richard, were they even selling computers with
Richard? I do think of you every single time I look at this motherboard because it is completely alien tech. I don't know if this is going to show this, but the back.
It's too green.
Look at how beautiful the back of that is.
That is gorgeous.
That is gorgeous. Right. Our memory sticks are right here. Hold on and I will pop the memory sticks out and we will see how.
Robbie's taking the Dargendorp challenge.
128 megabytes in that stick. And 128 megabytes in that stick. There you go.
Yep.
So we've got 256.
Megabytes though, not gigs.
Yeah, megabytes. 256. There you go, dog. Sound better?
Man, could you imagine how awesome it would have been playing Age of Empire or Diablo 2 with 2 megabytes? That would have been.
Can it run Crisis?
All right. Wish you all well. Peace and respect to you all. Going to go now. Have a great evening. It's great listening to you guys talk.
Video games.
It's great talking to you, Richard.
Peace.
Peace and love, Richard.
Peace and respect.
Oh wow.
There was
It's
some
like quiet.
ambience.
Yeah, he had an ambience that he was bringing with him.
What frequency does Richard vibrate at?
I mean, I don't know, but if he goes to a higher frequency, he'll be more godlike. Or God damn it, I fucking hate that.
Too many computer parts in this fucking living room right now.
I gotta say though, I really enjoy watching people dissect spirit science and channels like him, but particularly him, because there's just so much wrong there.
With spirit science?
Yeah. Yeah, and I know about plus like there's so much wrong about what he presents, and then there's the baggage because yeah, he has done very bad things.
Oh, I didn't know that about spirit science. Whoa.
Oh yeah, you can find a recording of him admitting to spirit science. He's this guy who
Oh, I know
does,
spirit science. No, but who is a proponent of it? Who did you say was a proponent? Spirit science is.
Nobody. People who tear him apart is what I like. Like,
have you never seen Spirit Science, Brie?
Oh yeah.
Oh, the animation is fantastic. I love the animation.
The animation is really good, and it's just that the content is
dog's balls.
It's impressively wrong.
Or even the concept of doing the animation with the voice sped up just a little bit to make it sound.
Yeah, I like that. I really do like that.
The whole aesthetic of it appeals to me. I've watched hours of Spirit Science, but it's loopy loony stuff. I watched tons of Gaia stuff. I mean, that's what my half of my channel is debunking stuff like that.
Right.
So,
now,
yeah.
This is a thing that I've thought about more so maybe 6 months ago than would be now, Brie. But it would be something if you were interested in. I'm not actually possibly financially stable to do this right now. Maybe down the line we could do this, whatever. But there is the Gaia channel, and I have been a proponent, a follower. I don't want to say I agree, and I definitely no. I'm going to make the statement I don't agree. Right, Michael Tallinger. I have been following Michael Tallinger for a very, very, very long time. All right, Ancient Aliens, all of that sort of stuff. I've watched a fuck ton of his lectures purely for entertainment purposes, same as we watch Ancient Aliens. As you would go to these YouTube channels and stuff to do your thing, and you disagree with them all. I've reached out to Michael Tallinger a couple of times. On one occasion I got an automated response back. But on one occasion I got a response back from him. He said he was busy and asked if I could wait a few months until he finished what he's doing. He has recently announced that he's finished his massive scam rip-off fucking thing going. He owns an area in South Africa, which he now puts forth as these, what we have proven to be cattle areas, that are areas of rocks that they piled up to keep cattle in. These are outports of energy from aliens. He's found Anki's Palace. He's found the area that aliens found us and converted us into humans. And he's even got an African shaman on video like this is where I was brought to be converted into a shaman. This is a story that's been going through all
so
Michael
what you're
Tallinger.
telling me is that you want me to come on and talk with this guy with you, right?
No, what I'm telling you that we have to pay for the rights to do this and pay for the subscription to Gaia for us to be able to do this. They have just went and handed Michael Tallinger an entire series that he can go and do all this ancient alien mad evolution bullshit. And for us to be able to critique this, we must pay for it. That's why
we must have Gaia. Yeah, I got what you're saying.
The Gaia network. There is the Gaia network. You know of
right,
the Gaia.
Right. The Gaia network. Yeah, I just did the mantis insectoid alien video thing on there. It was quite the wild
Michael
ride.
Tallinger is a proponent of stitching. All right, he bases an awful lot of his stuff on stitching. He also brings in an awful lot of the idea of acoustics. He is a believer that the ancient aliens were able to build the pyramids because they had acoustics that could control shit. There's some guy in America built a mini pyramid, and he said that he did it by using the same technology that the aliens did, but he didn't want to show anyone, and he could do an awful lot of building in a short period of time. But let me finish, get the thought out. It was in a newspaper article, and this is a point where you can look it up and confirm what I'm saying, or find out better that I'm saying it. But these kids snuck in to watch how he was doing it. It was in the newspaper. They went and told the 1920s, whatever it was, and he was banging two cone-shaped stones together and using them to levitate shit, and that's how he built this. So newspaper article, cone-shaped stones, pyramid. That's your Google search. You'll get better information than my memory.
I just find it interesting how this guy could use reproduce the same methods that the extraterrestrials used to build the pyramids when the pyramids weren't built by extraterrestrials.
Oh yes, I agree with you. This is
Are
why
you
it's
saying they were
entertaining.
built by brown people?
Yep.
No.
What? I'm sure you don't. Have you read
Welcome back,
history, Doc?
Savage. Savage gets 2 weeks. 2 weeks. 2 weeks. Thursday, 2 weeks.
You know, but I gotta be honest, Weasel. The look I get from people when I say that look, just because a bunch of white Europeans didn't do it doesn't mean it wasn't capable of being done. Like, let's not act like brown people aren't the ones who ultimately came up with most of the technology and the philosophy and all that stuff that we use today. Because it wasn't white Europeans. Now, they came up with some stuff during the Enlightenment, but half the shit that they thought up had already existed for almost 1,000 years in the Muslim thinkers and the Indian and the Hindu thinkers and all that stuff.
And the Chinese.
Yeah.
Yeah.
I know where the word algebra comes from.
Do you think
an algorithm?
I think it's absolutely fucking brilliant. I think just on that topic of where things come from and stuff like that, Pythagoras' theorem that everybody in the world, in the Western world, and all people who are educated and things, we all know of Pythagoras' theorem. You know, a squared, b squared, c squared, all that shit. Pythagoras had a fucking religion follow him around.
Mm-hmm.
Does people know? Like most people don't know that. That, you know.
Yeah, there's an apocryphal, I imagine, tale of like I don't think it was Pythagoras. It was whoever figured out that the square root of 2 is irrational. And there's the story is that like the Pythagoreans like killed him or something.
Yeah,
because
possibly.
they were like
I don't know if that.
It was against their religion for two quantities to be incommensurate with each other.
Oh, really? I hadn't heard of that. That's wild.
Yeah, I think it's, but I think it's like I don't think it's something that like was made up in the 20th century. I think it's like an ancient apocryphal thing. I don't know though. But it's interesting because I mean, square root of 2 irrationality is not difficult to prove. It's a lot easier to prove that than it is to prove the Pythagorean theorem. In my opinion.
1 + 1 took a fucking book and people still.
I'll be right back.
But I guess that's partially because you're proving it like just with the numbers, and our concept of numbers and like the ability to map numbers onto physical distances we take for granted a lot of subtleties in our understanding. Like the number 0, which came up when you and I were chatting way earlier. But rational and irrational numbers, the idea that it's not possible to square a circle, it seems like it should be given a compass and straight edge, for example.
You're just making me think of fucking Elena now, and it's because as a father watching these things develop, and you're talking about brains and how our brains naturally develop and how our brains can naturally do certain things, you know. So if I threw a football at you or threw a tennis ball at you, you reach out and grab it because technically your brain has went, this is the force, it's been thrown, there's the angle, blah, 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 blah. But you reach out and catch it. We colloquially call it your hand-eye coordination. And it's really simple, and that's it. And there was a period of about 2 years ago, you know, well, it was 2 years ago, sorry, where there was a period where my wee girl was actually learning that, you know, and watching that, from throwing it at her and her going to, you know, watching that develop and realizing you can see that she's getting this angle but not getting this angle, you know, then you can see where she's getting distance and being, you know, and it is something. I'm sorry, I'm just rambling about it, but it's a practical application of what you're talking about, how our brains do this, but it does take a development. It takes practice.
Yeah, I think somebody wrote a book. I think I saw a talk by this guy who wrote this book, but I can't remember who. It was when I was in college, titled "Dogs Can Do Calculus," because if you're with your dog on the beach and you throw and you start in the water and you throw a ball to another spot in the water, if it's far enough away and you guys are close enough to the beach, the dog will run out onto the beach because it's faster to run and then go back into the water. Whereas if you're further away from the beach, it won't do that, and it'll just go straight to, it'll run through the water or swim or something, just and go do it. And it's pretty good at knowing when it's optimal to go the other thing. And to do that rigorously and mathematically, and to show exactly how far one is from the other, you have to like do the easiest way is, I think, the calculus of variations. It's not easy. I couldn't do it if you just asked me to do it right here. I don't remember math well enough. That's not a piece of math that I use a lot.
Again, being a proud daddy, our meetup point where we do the whole swap over on a weekend on a Sunday where we meet is a community centre with a football field. Now it's not a full scale, big football field like a proper one, but it's a football field, and people don't be playing football on a fucking Sunday when we meet up. There is a path to walk around it that a lot of people use for dogs, and she brings her little big rat. I don't know, it's a fucking Shih Tzu crossed with a Chivon or some fucking thing. I don't know. It's this. Anyway, she walks the dog either, whenever it arrives. And my wee girl has, knows the angle. It's like, go left a bit, daddy, right a bit, daddy, go straight. And when we're coming to it, we come in on what would be, if you're looking at it like this, the bottom right-hand corner. And depending on where her mother's arrived relative to us, she's like, right, you need to go left a bit, right a bit, straight. She can figure that angle out to where it is. Now, she used to aim for where the mummy was, and she'd ask why I'm changing, and that's what I've now told her. You have to think where the mummy's going to be when we get there, rather than where she is now and where we're aiming. It's... Yeah. I'm telling you, man, quantum gravity. I'm dropping all these hints into her head. Quantum gravity. We have been rambling for a while, and I think everybody's been physicsed out and mathed out, and so I do want to give the floor to Leo because he said very little, and I know that he likes to talk. So, Leo, what would you like to say on the topic of what is your favorite point in physics relative to you, more so relative to what's happened in the field of science?
I don't think I understand what you mean by what my favorite point is. Like what my favorite invention or what my favorite model or theory is, something like that.
Something that happened in you in your upbringing, an anecdotal story of a physics thing that meant something to you. Like for talk's sake, you walked out and an apple hit you in the fucking head and you became Newton. That's an anecdotal story, but it's a physics thing.
Oh yeah, I don't have any of those.
Do you have a favorite historical story?
Could someone explain this to Leo better than me?
The way I sort of interpret it was, I didn't answer it in that particular way.
What's your favorite
I'm not sure
moment
I've had
in physics?
Huh? What's your favorite moment in the history of physics is another way of putting it. I think that's closer to how I answered it originally.
That's what I'm trying to get at.
And the emphasis was on it is something of like significance in some sense, but it can be just because you find it particularly fascinating.
Well, something of particular importance that's somewhat overlooked, not entirely overlooked, but it's something that not a lot of people know about was I believe it was Paul Dirac and his discovery of antimatter in his development of relativistic quantum mechanics, which eventually developed into relativistic quantum field theory.
Yeah, Paul Dirac is underrated, I think.
Very underrated.
That's exactly what I wanted.
Yeah, there's a particular biography on him, which is one of the few biographies I actually read all the way through many years ago, and it's really good. And he was a very taciturn man and was brilliant and did a lot of shit. Like the Dirac equation is sort of like it's like what happens in Pokemon if the Schrodinger equation were to level up.
That's
sort
a
of.
mad fucking analogy, but that's a perfect analogy for the.
Yeah, that's why. Cause,
Can I steal
and
that? Because my wee girl likes Pokemon.
yeah, sure.
Okay, feel good now.
Yeah,
Remind
the
me in
Dirac
3 years.
equation is very.
Yeah, remind me in 3 years.
Yeah, it's really interesting stuff. And he also like with he had that idea that like a single electron is like going forward and backward in time, and like there's some issues with that, but there's a lot to be said for that too, I think. And yeah, antimatter, he came up with it basically. He was the first one to, I think, really kind of formally propose it. That's pretty nuts.
I personally don't know if I can answer this question myself because I have an awful lot of appreciation for different things, but I think if I had to find a favorite, it would be more leaning towards before. Even though a lot of my love and a lot of where I am now comes from astrophysics and quantum and Einstein and everything after Einstein, not necessarily these people. I feel
Just got some music stuff going on here. I gotta bounce, but I'll be maybe back in a little bit. Okay.
Oh no, I'm gonna be ending this in about 5-10 minutes if you want to hang about.
Okay, I can hang about.
Yeah, that's what I'm just ending up. Yeah. I would find that I can't remember the particular equation, and I can see it in my head, and it's sort of in around the generation of Newton. And you know the guy that had the ramp and he was figuring out speeds with the ball falling down. You know, you're talking about the guys who tried to prove that gravity was real with the two balls. The technology that they had being so limited, you know, no digital, everything's analog, everything's mechanical, you know, having to do what we do now by just going boop, boop, and they have to do this fucking mad thing. These are the makers, the movers in physics, the people who started it all. If they didn't spend, you know, their spare time, like a lot of physicists in them days were not trained in physics. A lot of physicists in these days were maybe mathematicians or maybe a rich cunt that was bored. A lot of time, rich cunt that was bored, you know.
Well, that was most academics like about, I'd say pretty much pre 1850. Most of the academics, most of like the biggest names in intelligentsia and academia throughout history were wealthy people, because poor people who had to work all day in a field didn't have the time to sit and think about these things and read books and study and consult people at universities, because if they were seen on a university, they'd probably be beaten half to death.
And there's a story and there's a whole video. I think Veritasium did it. I can't remember. And they brought to my light the idea that what universities used to be, and I can't remember the time frame. Leo may be able to help me, and Michael definitely could with the history of. But the main mathematical teacher in the university was there because he could prove his ability. There was a particular person who had figured something out and never told anyone, so anytime he was challenged he would ask this question, and it was someone else that had figured it out on their deathbed, and it was their son that then got it. There was a
Cardano.
Pardon?
Cardano and the solution to the cubic is the story that you're talking about. Cardano and the solution to the cubic. Yeah, it's a favorite story. Yeah,
right. And that would be my anecdotal personal favorite story, because it shows, number one, math. Number two, you should only be the best if you can be proven to be the best, and anyone can challenge you. You know, might makes might and all that, right? And number three, it's human nature. Motherfucker held on to it because he wanted power. You know, it sort of, it shows everything, and that would be my anecdotal favorite moment in physics or mathematics. Yeah, I like that. That's a good decision. It's on video now, so I can't take it back. Bree, have you got one before we ended? Don't say Darwin.
What are we doing? Sorry, do you know
your favorite moment in the history of science, your history of math, your history of physics?
I guess it would be, well, for right now, mapping the human genome.
Oh wait, we were supposed to give our favorite one?
Yes, anecdotally to you. I made it very clear and even asked the panel if they could explain it better.
Well, no, I heard
Yeah, wait,
I shouldn't be interrupting Bree.
Leo,
I
it's
said
not
I
on you.
shouldn't be.
It's
Other
not
people
on-
can.
no,
I realized that I just did that.
You're right.
I
Doc.
can't
No, you're
explain
fine. No,
hyper.
that's about it. Yeah, that's been within my lifetime too, so that's pretty awesome.
That's a
Was
good
that
one, though.
2000? Yeah.
What was
I
the
thought it had to be
number?
like an important one. I didn't know it had to be our most well, I don't really have a most favorite.
Okay, that one
I
is
don't.
Anecdotal by itself.
Well, yeah, no, it's important. That's why I said it, but it's not really my most favorite. I don't really have a most favorite. I don't really know a whole hell of a lot about electroweak symmetry breaking. Weasel would probably know much more about that than me.
I doubt it. I doubt it.
Oh, I
but
love this. The both of you
the
are licking each other's assholes. Keep going. Go on ahead.
The development of the Braut-Englert-Higgs mechanism in the 1950s, actually, I think it originally was, wasn't it? Late 50s?
I think it was 62, but I'm not sure.
Okay,
I
yeah,
don't-
you might be right. I'd have to look it up again. I know it was somewhere around the early 60s that the Braut-Englert-Higgs mechanism was developed by, I know Peter Higgs, Francois Englert, and Braut's first name I can never remember.
Yeah, I don't. Yeah.
Robert Braut. There we go.
There you go. Has Bree had enough time to think of one while Leo recreated?
Is the Human Genome Project not? What 2000?
I thought it just looked like you were looking up some more stuff. when you
Oh
said
no,
it.
I was checking. I was checking the dates on it so I could come back and say
No,
yeah.
it-
started on
Well,
this-
that's what I'm saying. Would you like to make an
Yeah.
addition to what you said?
Oh yeah,
You're doing?
you add the year 2003 on there. We've mapped so many other genomes since then.
Well, when
we
did it
mapped the
start,
first-
though? That's the other thing about the Human Genome Project. When did it start?
Didn't it start in like the 40s or something?
1990 is when what we consider the Human Genome Project officially started, but there was a lot of prerequisite research that went into that, like mapping. We've mapped like Drosophila's genome before that. When did we map Drosophila's genome?
But
Right, so
I
has
think
everybody had their bit? Everybody's had their
Yeah.
time. I want to say thank you very much to the guy whose waist size is the length of pi. Oh no, that's not what it says.
it's my
did you
password,
teach-
man. I'm trying to give people my password. It's very straightforward. My password is the last 12 digits of pi.
Yeah, easy
Not
peasy. Easy peasy.
Oh man, there's a lot of things that you did in that sentence that just open up a whole can of set theoretic worms.
It's a fucking joke. Take a deep breath. It's not a philosophical. Oh, everybody's having a heart attack. No, take your t-shirt off. Take your t-shirt off. Throw it away.
About my pick, about when it started. When do you think that the first gene map was submitted? You guys never gonna
1840.
get this.
Huh?
When do I think the first gene map was submitted?
Yeah, for
I don't know. Like, is that when you have a gene and you know what the nucleotide sequence is?
Yeah, it's when what is it? It was first published. The first published with the 6 genes, and everything mapped.
Like the
out
very
on
first one ever, or the
Yeah.
first
And
one
it was
Oh
for
my
like-
goodness,
human?
how many times are
It
people
was
going to
like
say the same fucking thing? Just
Drosophila
shout
by
I
a
know.
number
I'm
out.
trying to ask for clarification
Shout
on
a
the
number.
question being asked. Is this like the first gene map ever, or the first one for humans?
The first one published.
Ever
it is
for
like
any
a
gene map,
Drosophila.
not
Just
just
trying to
specifically
make a
humans.
joke and everybody's running. Just shout a fucking number. 1840. I shouted 1840.
Well, I would like to know what it's. How can I answer a question
That's
if I don't
way too
understand what's
early,
being
Robbie.
asked?
I
1918.
73.
That's really close, Leo.
Wonderful.
1913.
Damn it! Damn it!
Brilliant.
I knew it was gonna be in the
Bro,
teens. I was like, it's
I
gotta
didn't-
be in the
I
fucking
didn't know what we
teens.
were talking about.
It's okay. Yeah, no,
I'm like,
I was shocked. If you would ask me to guess, I would have said sometime in the 60s. So
Yeah.
Leo was a lot closer than
I was thinking the 40s or the 30s, and then I was like, nah. But she said like, you're really not gonna get. And I was like, I bet it's in the teens. What, like
Yeah.
17, 18, or something like that? Nope,
'Cause you don't-
13.
You don't
I
think
promise
about
I don't
genetic
know.
research before World War II, right? It's just like
Well,
not.
genetic research I do. It's just that I don't know if gene map means it requires knowledge about DNA, and I know
Well.
DNA wasn't known then. So like,
Yeah.
I just don't know enough about what the term.
Well,
gene map
you got to
means.
remember, genes refer to a higher order structure constructed of DNA. Like, isn't that generally chromosomes? Isn't
think-
that what?
But if
Wait,
you're
no, I'm
mapping
stupid.
within
Genes have-
gene, then I don't know. because I think you can break it down eventually to nucleotides. So I was
You
already
just
done with
snap
that.
It's the unit of heredity that is transferred from parent to offspring.
Sturdivant
Okay, yeah, and
mapped 6 genes. He mapped like one for eye color and wing shape on Drosophila. That was.
Everybody just keeps going and going and going. You can all chat. I've muted everybody. Mute button. Mute button. You're all insane.
You
I don't know
asked
what
me
you're
a
trying to
question,
do.
Robbie. You asked me a question.
There's actually several different definitions of gene in biology.
Mm-hmm.
Trying to end the stream and everybody keeps starting other conversations.
Unfortunately, none of them say a
Insider,
popular 70s and
MathPig.
80s rock singer.
Pardon?
That one's not in there.
Pardon co-host and me another person on the stream tonight that could talk over. Go on ahead.
I said nobody cares. We want to keep talking.
You can keep talking
Start talking about-
offline. Just let me go. Thank you everybody for coming. These are all amazing. Bree, I cannot wait to like give you a hug and like I don't know. Make sure you shower and buy a new perfume or something, you know. Like looking forward to seeing what Bree smells like, you know. Hugs for everybody. Leo, are you coming? There's 2 slots left.
Probably not.
You're missing out. You're missing out, man. £70.
Yeah.
70 quid. 70 quid. Math.
I don't know what a quid is because I'm from
Quid's
the
a
United States
pound.
where a pound. No, a pound is a measure of the force of the mass of something acting in a gravitational field.
So Leo's internet just broke. Okay. Thanks everybody for coming.
That's the measure of.
He's still going. He's like Josh Dawkins. He doesn't realize when he's been.
Is that right? Am I not? Am I?
See, still going. Still going.
Understand
Oh, he's still going. I swear to God, I give him a longer period to see if he'd catch on. Still.
now. What the fuck is even going on right now? I have
No idea. Man.
You're getting trolled.
Everybody, I love you all.
You're being trolled, Leo.
Well, no, but like I actually wanted it.
I'm seriously trying to say thank you to Mr. Dr. Weasel here. Hold on. Dr. Weasel, thank you very much for giving us your time.
So I don't get an answer to my question?
Oh my goodness, nobody cares about your question, Leo. We've all forgotten. Let me end the stream. You can continue.
Well, I actually have
asking.
forgot, and I actually was genuinely interested in an answer. So I'm totally glad that I forgot the thing that I was actually genuinely interested in getting an answer to.
Yeah, it's called being autistic. If someone interrupts me, I lose my trail of thought. You did it 3 times, and now I'm being forceful so that I do not remember. Because it's my channel, and ending the stream is more important than you asking your question live. Ask it after.
I don't care about whether it's live. I
Think
just
for
wanted an answer
yourselves,
to it.
people. Thanks everybody for coming. Bye.
I don't think it really matters though, because I don't remember what the question.